Hello everyone, how's it going? Today is Tuesday. We are having our lecture again today. So thank you all for showing up, all 30 odd of you. That's interesting. I thought that the class had more than 30 people in it. But, there we go. We have 40 people. I suppose I shouldn't be too, I shouldn't be too critical. Generally speaking, by the, third or fourth week of the semester, attendance in an actual lecture is down by about 50% as well. So that's about what you would expect it to be, I suppose. And I suppose the fact that things are, online as well, with respect to being able to access them afterwards, is also contributing. Anyway, hello, welcome. Things are going well, I hope. Let me hear a whoop whoop in the chat. Whoop whoop. Hopefully. Anyway, so, yeah. Oh, that's for what? Whoop. No, I don't want to close that tab. Jeez. Cool. Oh, we don't want to do that yet. Hello. So, I don't think there are any housekeeping issues to be discussed at this point in time. But, so I guess we can move right into our lecture material for today. Good, I got a whoop whoop. Excellent. Always important to get your whoop whoops in the morning. So, thus far in the course, things have been more or less in the vein, this is how you did things in Python, this is how you do equivalent things in C. There was some new material presented sort of with respect to computer architecture and the way that the stack and the memory is organized and that sort of thing. But largely the course so far has been, this is how you do stuff in C, as opposed to doing it in Python. This time around, we're going to be getting into some stuff that is perhaps a little more out there, stuff that you guys may not have seen so far. It's unlikely that you have seen it so far, I will put it that way. A lot of the topics that we are going to be talking about this week are, shall we say, a bit more heavily oriented towards computer science and algorithmic analysis. This is very important stuff that you guys need to know, essentially. And, at a certain point in the mechatronics program, this kind of stuff, you kind of just had to absorb it by osmosis from all of these, software engineering people that all your courses end up being cross-listed with in third and fourth year. But some of it I'd say should have some explicit coverage. So I hope there are certain points in this lecture where I will say, you guys should pay attention to this part, and hopefully you take the advice. But at any rate, the general topic for this particular week is arrays. We are going to array all kinds of information before you. So let me see what people are talking about. Cool. This is my this is my wife's actually. I have one that says "Good morning, gorgeous." We thought they were so cute that we had to buy them. Anyway, I like the mug. As a mug goes, it has a handle that is far enough away from the actual cup that you don't risk burning yourself, and the volume of the mug is sufficiently high to be able to handle a Mr. Moore-sized cup of tea in the early afternoon/late morning. So there you go. Oh, that's... I'm sorry. Don't pay attention to that. There are lots of comics coming up. There are 4 comics in this lecture slide series. I hope you like it. Anyway, arrays! This is the table of contents. This is the stuff we're going to be talking about this week. Arrays, like tuples but more annoying. Strings are character arrays. Bubble sort, big O notation, insertion sort, shell sort, and search algorithms. So, arrays, the simplest data structure. I'm going to read the comic to you this time. Man, you're being inconsistent with your array indices. Some are from 1, some are from 0. Different tasks call for different conventions. To quote Stanford algorithms expert Donald Knuth, "Who are you? How did you get into my house?" Wait, what? Well, that's what he said when I asked him about it. The joke within the joke is that the hat guy imagines he has a choice. So, in Python, there are many data structures to choose from. You've got tuples, lists, dictionaries, sets, and strings. In C, there is only one. The only data structure supported natively is the array. If you need something more complicated than an array, then you either have to find a library for it or define it yourself using some combination of arrays and structs. Structs are something that we're going to cover after the break, after we talk about pointers, so don't worry about structures just yet. We're going to talk about them later. So, what is an array? An array is a contiguous segment of memory which may be accessed via linear indexing. Contiguous, by the way, contiguous. Sharing a common border or touching. Next to, this is the one that I actually mean, next or together in a sequence. So the idea is, when we're talking about contiguous memory, and I know that's like a $10 word at this very early hour in the morning. When we're talking about contiguous memory, what we're talking about is continuous. It's like continuous, but it has like a geometric application. The memory is all together. It's one block of memory. There's nothing in the block of... it's not interrupted at any point by something that's not array. You start at one memory address, you go through to another memory address, and everything inside there is part of the array that you're talking about. It's contiguous memory. Contiguous is one of my favorite words, by the way. So, all elements of an array have the same type. In Python, if you had a list or a tuple or something, since Python is dynamically typed, any of the elements inside of your tuple may be of any data type. It doesn't really matter. You can mix your strings with your integers. Python doesn't even consider characters to be different from strings. So, you can mix and match, and you can have this hodgepodge potluck of all kinds of data types within one data structure. When you are working with arrays in C, that is not how you do things. The size of the array in strings, the amount of memory that array takes up, is declared up front, and it has to be fixed. So, in order for the compiler to know how much memory to give to your array, it has to know how big each of the elements of the array is, because the amount of memory an array takes up is, not unsurprisingly, the size of the array multiplied by the amount of memory each element in the array takes up. So, that's why arrays are composed of one data type and one data type only. And that's not strings. Strings are different. We're going to talk about strings. Arrays use zero indexing. You guys should be well familiar with zero indexing by now. Arrays are static. The size of an array does not change during execution. This means that the size of the array must be known at the time of declaration. There are ways of getting around this, but not without pointers. We're going to talk about pointers next week. Yeah. Notice that, so there's a difference between an array being static and a tuple being immutable. So with tuples, you can't assign things to them. You can't say, t at 4 is equal to 7. That's a type error in Python. Arrays are more like lists in that sense, because you can do, array, a at 7 is equal to 13. That is a legal and valid command in C. You can modify the things inside of arrays after the creation of the array. Totally legal. But in a lot of other respects, like in terms of the memory management, arrays are very much like tuples in Python. So, syntax, my friends. An array is declared in the following manner. You have the type, you have the identifier, and x can be some number. It can also be left off. Ooh, I have a question. I'm going to take that question now. Is array like a table? I don't know what a table is. Tables in like SQL? Question mark? So, because the array has been declared as an array of integers, that the size of an int is the size of each of the elements of the array. The array identifier is declared in the manner that you might expect it to be, and this right here, this indicates that you're talking about an array. The only syntactic difference between this and the declaration of a regular int variable is these square braces. And we're going to see all of the variations that we can take on those. Is it like a table? No. Tables in SQL have a fair amount of bookkeeping that's sort of integrated into them already. You have the schema, and your various columns correspond to various types of data. The fixedness of the types of data is very similar to arrays in C, but a better analogy for a table in SQL would be an array of structs in C. So a struct would allow you to get the sort of data grouping that would be similar, like it's very similar to a record in SQL, and you would collect a bunch of these structs as an array, and that would be similar to a table in SQL. Hopefully that answers your question. So, note that x must be either an integer literal or an expression evaluating to an integer. So this has to be an integer. Must be an integer. This rule applies to array indexing as well as declaration. So this has to be an integer. On declaration, an array is filled with junk data. So this is a declaration, but not an initialization. If you wish, we're going to get into how to initialize arrays in just a slide or two. But this sets the memory aside, but it doesn't fill it with anything. And because C is C, when you declare that memory as belonging to that identifier, we're not overwriting it with zeros or anything, not unless you tell it to explicitly. So it's in fact filled with junk data. Yes, arrays may be indexed using the array index operator. So C at 7 is equal to 5. This is a valid statement. This assigns the value of 5 to the array element at index 7. This binds on the same level as function calls, so very, very tightly. you don't have to worry about addition interfering with how your array indexing is interpreted. You can, for all intents and purposes, consider this to be an identifier, even though it's technically an operation. And as we'll see later, the index operator is syntactic sugar for some pointer operations. But again, we'll talk about pointers when we talk about pointers. I've got a few questions. Pop, 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 pop. Does C allow for 2D, 3D, ND arrays? Yes, as a matter of fact, it does. We're going to be talking about multidimensional arrays at the end of this section of the lecture slides. But in general, just like Python does a 2D list as a list of lists, in C you do a 2D array as an array of arrays. So the manner in which you can use arrays syntactically more resembles lists, but the way in which C works with an array on a memory level is much more similar to a tuple. So that's why I think they're tuples, but more annoying. So the question is, does this statement only work on an initialized array? And the answer is no, it actually would work on an uninitialized array. In fact, this might be the manner in which you choose to initialize your array. So because C keeps track of very, very little information about its own variables and identifiers, C doesn't actually care whether or not the array is initialized or not. Reading data out of an uninitialized array does not constitute an error, not even a warning. You, the programmer, are responsible for making sure that your arrays aren't filled with junk and that junk is not being read into later parts of the program and being used as real data. That is your job, not C's job. C is very good at passing the buck. Tuples can't be edited, but arrays can. Arrays can be edited, yes. Arrays, in that sense, are mutable. Yeah. Cool. Good. I like the amount of interaction that's going on in chat right now. I was kind of worried that when we moved over to doing things on Teams, that the amount of activity that was going to happen in chat would drop off precipitously, but it seems like people are still participating more or less the same way they would. I guess the other thing is, I compare you guys too much to 1MD3. You guys are, more chill second years, you've found your chill, whereas the 1MD, the people in first year are all, super nervous about everything, and, the chat is, filled with people, you know? But it's all, the class is also 3 times the size of this one, so maybe that's a bad analogy in that respect as well. Anyway, so, pretty printing arrays. This program indicates some interesting things about how you might go about working with arrays and how you might show them. So, one of the things that printf does not have is a way to quickly and conveniently print out an entire array. So in Python, it's real easy. If you have an array, you just ask for it and it prints it. In C, you actually have to manually loop through your array and print out each element individually. So this program prints out an array in the manner that you would expect an array to be printed out by something like Python. Let me just check to see if I have this code anywhere, and we'll execute it for you. Is this it? This is a version of it. This will do. So, gcc arrays.c out arrays. Who cares about wall? Ha! Fine, I'll run it with wall just because you didn't ask for it. Ooh. Yeah, okay. Unused variable bar. That's fine. Oh, I was testing that that thing with the dollar signs. Anyway, if we execute array, no such file or directory. What? Arrays. Fine. Be that way. So notice this doesn't work, right? You get nothing. You can't just, and this is, by the way, for printing off a string, I think, ls. Or, no, I think it's a float? I don't know. Anyway, the way that, so what is indicated here is the first thing that's being actually printed off is this statement here, %p. So we haven't covered %p just yet because, once again, we haven't covered pointers. But that's how you print a pointer. Printing a pointer is almost completely useless. The data that's in that is contextual to the operating system you're operating on. That is the actual memory address at which the array is stored. So because I'm not using the address of operator here, which you would use if you were using scanf, that should indicate to you that this identifier corresponds to a pointer, rather than, you know, it's not like the first. It's actually pointing to the first element in the array. But at any rate, if you wish to print the array, then you have to loop through it for every element in it and print that stuff like that. There you go. That prints it. So, some interesting points. Number one, notice that this is an expression evaluating to an integer rather than just an integer literal. That's completely legal. This is how you would this is how you write an array to initialize it. Notice that we are using curly braces here, not round braces, not square braces, which is typically lists. Arrays are delimited by curly braces. Notice that the size of the array that we are initializing foo with here, that's actually smaller than the size of the array foo. The array is of size 12. 12 spots have been declared for values, and we're only using 6 of them here. In the output, you can see what C is doing, so to speak. It's just initializing everything else to zeros. So, yeah. So if you want to quickly initialize an array completely to zeros without having to, you know, like if it's an array of like 600 things, that would take a long time, right? So if you do this, you'll just get initialized to 0 without having to do any of the work, which is nice. But that's kind of a hacky way of doing it, but you know what? This is C. If you're not comfortable with doing things in hacky ways, then maybe you'd be more comfortable in Python. Oh, snap! Anyway, I think I have a... Will we be tested on your mug? No. Yeah. No, you won't be tested on my mug. Although I could write a test question about the mug that, you know, as long as all of the information you need is contained in the question, then everything's fine. If the memory is all predefined, is it possible to append? Not without some pointer stuff. With pointer operations, it's possible to do anything you like. However, just using arrays without using pointers, even though using pointers is using arrays, but you know, if you wish to append something to an array, you have to create a new array that is the size of the appended thing larger, and then copy the old array into the new array, and then copy the things you wish to append onto the end of this new bigger array. That's how you would do that. It's easier with pointers. You can do it more dynamically, but no, like when you're just dealing with arrays, things like the size of the array are hard-coded. It's better to think of it as hard-coded. Yeah. So, is there a way to show that there are 6 free slots? The concept of free slot doesn't really mean anything. All this does is the compiler assumes you meant this. That's all that happens there. You can... Oh, there is a way to tell how big the array is, though, and that's in a slide that we're going to cover once I stop talking. It's a little ways down, but we're going to get there. So, patience! Patience, my friend. So if you wish to visualize an array, this is how you would go about visualizing it. This is from the textbook. You have a bunch of spots in memory, which are contiguous, and each one corresponds in order to the index that it means. So I guess the thing to understand from this slide is that the position in the array is directly the position in memory. There is a one-to-one mapping between your array index and your position in memory. That's a good thing to know. Ha. Can I give you an analogy for arrays conceptually? An analogy for arrays conceptually. Arrays are like trains. So imagine your computer's memory as a train with a bunch of cars, right? Declaring an array is like being given a ticket. Let's imagine you have like a party of people, right? You got a bunch of people, so you're gonna rent like you're gonna rent. You're gonna buy tickets for like 7 of the cars on the train, right? Your ticket will tell you which cars you've been given, right? And that's kind of like what that's kind of like what an array is, or / what a pointer is. Hopefully that's a okay analogy. Am I muted? Hello? Hello? Testing, testing. No, I'm not muted. I think it's on your end, dude. So there you go. Hopefully that's a good analogy. So, compiler warnings. This is related to the previous thing. Oh, yeah, so if I had actually run this like I had said, if I'm trying to interpret C as an integer, that would come up with the following warning. Format D expects arguments of type int, but argument 2 has type int star, i.e. it thinks that your array is an integer pointer, and that would be the problem. If you used ls, that would be a little bit better, but, you know, if you use ls, you get some sort of output. You would interpret it, as a long signed, or something like that. The memory address, and of course, the point of this, okay, a couple of things. Number one, if you leave out the initialization, let's take a look at what it does. There. So, the values that are in the array are essentially random, although they're not random like like a random distribution function. They are old data that is no longer needed by the CPU that has been given to you for the purposes of your array. So you'll notice there's like a heavy leaning towards things being 0, heavier than you might expect. So this is what I mean when I say junk data. Also notice that the memory address that we have been given for this array has changed from the previous time we've run the program. And that is a very important thing to know about pointers. I know that we're talking about pointers a lot for a class that's ostensibly covering pointers next week, but arrays are pointers, so best to just, noodle around some of these concepts for a week before we get into pointers hardcore. So, for pointers, the actual value of the memory address is going to change each time because the CPU is in a different state every time that the program is run. So it's going to give you different memory. The take-home message there is you should never assume that a pointer is going to be any particular value. That would be dumb. Pointers should always be dealt with relative to their values. So in the case of the example of the slide, the array C is not given new items, just contains junk data as I only initialized bar. Yes. So if it's uninitialized, it contains junk. Period. Good. So let's analyze our pretty printing of the array. Just like a lot of things in C, there are no free lunches. You can't print a whole array just by passing the array's name to printf, as the array identifier is really a memory address or pointer. An uninitialized array is full of garbage data. To initialize an array, provide a comma-separated series of type-correct literals or expressions delimited with curly braces. That's a fancy way of saying, just do it like this. If the initializer is smaller than the declared memory, C will backfill with zeros. That's a thing that you can use. If you initialize the array, you may omit the specifying size. The size of the initializing array will be used. So that's a new point. So let's say, you see how no number is specified here? C is just smart enough to see that it's being initialized with 4 values and assume that 4 values is what you want the size of the array to be. It'll do that, but very little else. So you can leave that. You can leave the number out here if you have an initializing array. Oop, jeez. I hate clicking that bar. Oh. All right. Cool. So, I have a couple of questions, maybe. So, in the case of the example, oh yeah, it's all come together. Yeah, I approve of memes being posted in the chat. Ooh, I suppose that was a thing that's an advantage that Teams has over YouTube chat, is you can't put a meme in YouTube chat. I approve. So, let's talk macros. Macro man. So, it seems like kind of a pain to have to hard code our array sizes. There has to be a better way! So it turns out that you have available to you what are called macros. This is a preprocessor directive, and you can essentially assign a value to another tag. So essentially, the idea is that during preprocessing, the preprocessor is going to look for every instance of this identifier occurring and replace it with that. So if you have to initialize a whole bunch of arrays or do some calculations based on some size of the array, and that size might vary, it might be a good idea to define it as a macro. Macros are kind of like constants. They're actually a little more useful than constants. They can do a lot of stuff because this doesn't have to be this doesn't have to be a literal or an identifier. This can actually be arbitrary code. Like this has no requirements of being syntactically correct. So you can actually use macros to do all kinds of crazy stuff, like finish off arguments and stuff. But anyway, lists of arguments. For now, let's just talk about using them to replace constants. But yeah, questions? Cool. Nope, I'm going to cover those questions once I'm done this slide, because I've been told about that. A macro is a preprocessor command which defines a character substitution that occurs prior to compilation. Think of it as an automatic find and replace operation. So, the first thing the compiler does, it finds all this and replaces it with that. We may use macros to replace all occurrences of the string size with the size we wish our arrays to be, enhancing modularity. Macros can be used for all kinds of things, which we will talk about in a later lecture. Towards the end of the course, we have scheduled a lecture on the preprocessor and preprocessor commands, so we'll talk about macros a little bit more in depth at that point in time, but it's good to have the concept introduced right now. So, questions? So there isn't a declaration of the arrays. You just use int or float or whatever you're putting in the array, and then C knows it's an array, and you use the curly braces. Well, no, you have to also include the square braces here. If you don't include the square braces here, then that'll be an error. Or it'll be, well, it won't be an error, it will be an integer. And then when you try to assign an array literal to an integer value, that will be an error, to speak precisely. That is memory in RAM, right? Which is volatile. So technically, if I just turned off my PC on and ran this program before anything else, would all of the values be none or 0, or would they have a random value? I would say, good sir, I challenge you to get your C program run before anything else on your computer is run, including your operating system. That's the thing to keep in mind, is that the boot sequence on a computer is going to fill up, that alone is going to fill up a lot of the RAM. So the idea that you might be able to work with pristine RAM that has never been touched by human hands, that's a bit of a myth, shall we say. Might be possible on microcontrollers, but on a computer, nah. You done, son. If I'm replacing constants, could I just use a variable? Yeah, you could use a variable to get a similar effect. Yeah, you could. There you go. The thing about a macro, though, is that it's, like, declared at the top of the file, so it enhances modularity a little bit more than a variable would. Also, variables can be modified mid-program, and constants cannot. But yeah, as with most things in programming, there's like a million ways to do any particular thing that you want to do. So let's talk about how you work with functions. Consider the following function prototype. Int star myfun const int input with the square braces. Input is declared as an array by the inclusion of the square braces. You can also use int star, does the same thing, means the same thing. Int star tells us that this function returns an integer pointer. Arrays in C are syntactic sugar for pointers. Incidentally, this is the way to do that. You have to use the star, because myfun with square braces doesn't mean anything, because this is a function, not an identifier. The const term locks the pointer so that it can't be modified. This essentially makes it read-only. This will prevent any of the array's elements from being modified, as well as the value of the pointer. Incidentally, if you want the array to be modified, don't make it a const. I'm just also sneaking in how I'm sneaking const in while I'm talking about this, because this should be fairly straightforward. If you want to be able to modify the array, just leave out the const keyword. You can do this with any argument, not just arrays. So essentially, int star here, square braces here, or an int star there. And that's how you pass arrays into functions and get them back out again. Oh, I forgot. That's a typo right there. I apologize for that. That's the LaTeX command for doing it like this. So imagine that looks like this. Sorry, guys. Anyway, questions? No? Okay. In Python, we have the len function to quickly and easily tell us how large our data structures are. You may be thinking, if I am expected to work with data structures, as it is becoming increasingly obvious that I will be, how is it that I might determine the size of the data structure I am working with, considering that is a thing that I might need to know in order to loop over it, for example? The equivalent function in C of length is size of. But, as with most things in C, it's a little bit more complicated than you might expect. Size of returns the size in bytes that the provided argument was declared with. So if you take size of the array foo, it'll return the size of the array in bytes. Fortunately, size of may also be used on variables of any type, not just arrays. So, if you want the number of elements in an array, you ask size of to give you the total size of the array in bytes, and you divide that by the size of an element in bytes, and that will return to you the length of the array in elements. The length of the array as we think of length in something like Python. Yes. Accordingly, the declared length of an array is equal to the size of the array in bytes divided by the size of any element of the array in bytes. It's typical to use element 0 because it usually exists. So int foo is 1, 2, 3, 4, 5, 6. Length is size of foo divided by size of foo0. That's how you get length. Again, there might be some library function somewhere that does that for you automatically, but this is how you do it with, basic constructs. Good. Accessing higher dimensions. I already kind of talked about this, I think, but let's talk about it in more detail. Linear arrays are all well and good, but what if I need to represent a matrix? This is how you would do that in the literal. Essentially, you would and this is how you do it with the identifier. You just use a number of square braces equal to the dimensionality of the thing that you're trying to produce. Yes. So dimensionality is indicated by the number of square braces following the identifier. So this is a 2D array, this is a 3D array. These are correctly thought of as arrays of arrays. Providing n minus k indexes to an n-dimensional array will produce a k-dimensional array. So, for example, if you have a two-dimensional array and you provide one argument, you will get a one-dimensional array out of it, or just an array. If you have a 7-dimensional array and you provide it four-dimensional arguments, you will get a 3-dimensional array as the result of that. So hopefully that's reasonably straightforward. Cool. I'm going to ask, are there any questions so far? Maybe there are questions. Maybe there are not. Which dimension is part of which declaration? Ah, that's a good question. The answer is kind of like whatever you decide. So let's imagine that you're dealing with like volumetric space, right? You're dealing with a 3D array. Let's say you have X, Y, and Z, right? C doesn't care which element is X, Y, or Z. The way that a particular argument the way that a particular ordering, the mapping between the order in which you give these arguments, these indexes, and whether you consider them X, Y, or Z, is entirely up to you. If you program it that way, then it will be that way. There's nothing in C that says the first one is X, the second one is Y, the third one is Z. You have to be relied upon as the programmer to use them consistently and in the manner in which you consider that they should be used. I highly recommend that this would be a good opportunity to put a comment in and say, the first index is X, the second index is Y, the third one is Z. That's kind of... In C, the programmer is relied upon to provide the mapping between the program and the semantic interpretation of the program. So, hopefully that's a reasonable answer. What will happen if the bytes in each element of the array are not the same? Well, that's interesting. That's actually illegal. So here's the thing, right? Let me pull up Get It. I'm going to use this as my chalkboard. So let's say that you have a two-dimensional list of array, a two-dimensional array, right? Something like that. 2D array. Something like this is illegal. Technically speaking. Although, if you declare something like this, C will backfill it with zeros, the same way that it backfills with, if you give an array that is doesn't define all of the elements in the array. And that's actually a supposition on my part. I haven't tested this yet, but that's what I think it would do. So the size of the elements in an array have to be fixed. So right now, what you're saying is that this is an integer array of integer arrays, right? So you could think of it as saying something like it's an int star of int stars with a certain declared size, right? So it's an array of arrays of size 5, right? The size of the array is part of the information provided by the type. The most crucial information provided by the type is the number of bytes it occupies. The number of bytes it occupies is the thing about the elements of an array that can't change. So, I'm sorry, in this case it's 3. So, if you are saying, I want an array of arrays, implicit in the array that you're making in the implicit in the array that you're making the element of the other array is the size of that array. So, you know, this guy has an implicit size, and that is 3. So, this is an array of arrays of size 3. So, you can't have them, like, even if you don't use them, the memory is still going to be declared. So hopefully that's some sort of, hopefully, I'm sorry that if that answer is a little bit confusing, but that's the best I can do on my first pass. Oh, and there you go. So in answering those questions, we have actually finished our time for today. So I'll stick around a little bit if anybody has any further questions. If not, we're going to say ta-ta, cheerio. Thank you very much for paying attention today. I'm going to get some lunch because I'm hungry. To extend the train analogy to multidimensional arrays, if you imagined that each car on the array had a train of the same size as a model train inside of the train car, that would be something like an extension of that analogy. It's like that, but they're also simultaneously all taken from the same set of train cars, and they're also the same size. So if you can imagine a train car that can contain a train with cars the same size as the car that the car of the train that the model train is in, then the analogy starts breaking down. Cool. Well, doesn't seem to be that we have any questions from the audience today, and the participation, the concurrent viewers seem to be dropping off precipitously. So I'm going to say good evening, have a nice rest of your afternoon, and see you all on Thursday.